In this lesson, we are going to look at some basic operations that involve complex numbers. I have this question here that says that if p is equal to 3 minus 8i and q is equal to 2 plus 2i, determine the value of the following. The first one is p squared minus q. So this is a simple case of just substituting into this expression here. So p is equal to 3 minus 8i, and that is squared minus the q, which is 2 plus 2i. And I'm just going to carry on and simplify this using the normal rules of algebra. So this is going to be, when squared, is going to give me 9 minus 24i plus 64i squared minus 2 minus 2i as I distribute that. And so that's going to equal, remember that I squared is equal to negative 1. So what is going to happen is that this positive 64i squared becomes minus 64, and minus 2 minus 24i minus 2i. I'm just grouping like terms there. So you'll simplify this to give you minus 57 minus 26i. So that's what this first one is going to give us. The second part of the question requires to divide these two complex numbers. So you've got q divided by 1 minus p, and this here, when we substitute, is going to give us 2 plus 2i, and that's divided by 1 minus what is your p? Your p is 3 minus 8i. And then we're going to simplify that the normal way, so that'll be 2 plus 2i, and 1 minus 3 is minus 2, and that's going to be plus 8i. Well, the denominator in the complex number system should not be a complex number, so we need to rationalize this denominator by converting it into a real number. And you know that we do this by multiplying it by its complex conjugate. Now the complex conjugate of minus 2 plus 8i is going to be minus 2 minus 8i. So whatever you do to the denominator, you need to do to the numerator. So minus 2 minus 8i. So we're doing this to try and convert the denominator into a real number. Now if I carry on here and do the simplification, we're going to get minus 4 minus 16i and minus 4i minus 16i squared. So when you multiply those two, and then in the denominator, you need to remember that if you've got a complex number, say z is equal to a plus bi, where a and b are real numbers, and another complex number or its complex conjugate is a minus bi, then z times z star is simply going to be a squared plus b squared. Okay, so in keeping with that, or you could just do the normal distribution of those two binomial expressions, you'll find that we now get minus 2 as my a squared, plus the b squared is going to be 8, so it's going to be plus b squared. Alright, and if I tidy this up, I will get 12 minus 20i, and this whole thing must be divided by 68. So as a side note, you need to remember that I squared is simply equal to negative 1. So minus 16 times negative 1 is going to give me plus 16. Well, sometimes the examiner will want you to tell them what the real part of this expression is going to be equal to, or what the complex or the imaginary part of that expression is going to be. So if I do that, I'll have, this is a positive 12, so 12 divided by 68 minus 20i over 68. So that my complex number in its simplest form is going to be 3 over 17 minus 5 over 17i. So the real part is 3 over 17, and the imaginary part is minus 5 over 17. So that's your final answer. Okay, let's make space here for the next part of the question. It's 2.3 2.13 and 2.1.3, and we're looking to find the real part of P minus Q. So in other words, just work out what P minus Q is equal to. So this notation means what is the real part of the complex number. Remember, the complex number Z is equal to A plus BI, contains a real part, so this is the real part, and an imaginary part, this one which we normally write as IM. Okay, so I want to work out this expression here, and from there determine which one is real and which one is imaginary. So P is equal to 3 minus 8i, and I want to say minus Q, and my Q is 2 plus 2i. Okay, so this is going to give me 3 minus 2 and minus 8 minus 2i, so that's I, and so your final answer is going to be 1 minus 10i. Okay, so when you look at this, the real part of this expression is equal to 1, so therefore the real part of P minus Q is going to equal 1.